Hello, this is Matthew from Simplilearn, and today we're going to go through part one of a two-part series on interview questions that you are likely to be asked if you are interviewing for a job that focuses on DevOps. So there are approximately 7 sections that we cover in DevOps. We go from general DevOps questions, source code management with tools such as Git, continuous integration, and here we'll focus on Jenkins, continuous testing with tools such as Selenium, and then you also have the operations side of DevOps, which is your configuration management with tools such as Chef, Puppet, and Ansible, containerization with Docker, and then continuous monitoring with tools such as Nagios. The first video is going to zero in on the left hand side of the screen. We're going to zero in on those general DevOps questions, source code management, continuous integration, and then continuous testing. Our second video is going to get into the operations tools, and we'll get into that the next time you come back. Above me there's probably a link that will take you straight to that video. So let's just get into those general DevOps questions. So one of the questions that you're going to be asked is, how is DevOps different from Agile? And the reality is that DevOps is a cultural way of being able to deliver solutions that's different from Agile. If we look at the evolution of delivery over the last 5 to 10 years, we've gone from waterfall based delivery to Agile delivery, which is on sprints, to where we are with continuous integration and continuous delivery around DevOps. The whole concept of DevOps is culturally very, very different from Agile. And the difference is that you're looking at being able to do continuous releases. What does that mean? The difference is that you want to be able to send out code continuously to your production environment. That means the operations team, the development team have to be working together. That means that any code that gets created has to be able to go to production very quickly, which means you need to be testing your code continuously, and then that production environment must also be able to be tested continuously, and any changes or any errors that come up have to be communicated effectively and efficiently back to the dev and op team. Another area in which I see that DevOps is different is really the response that we have for how we engage with the customer. So the customer is coming to your website, to your mobile app, to your chatbot, or any digital solution that you have, and has an expectation. When you're going through and actually doing a DevOps paradigm, the old model would be that you would capture requirements from the customer, then you do your development, then you do your testing, and there would be these barriers between each of those. As we move faster through from waterfall to Agile, what we saw is that with Agile, we were able to respond much faster to customer demands. So instead of it being weeks or months, sometimes in some cases years between releases of software, what we saw was a transition to weeks and months for releases on software. Now we see with DevOps is that the release cycle has shrunk even further with the goal of continuously delighting the customer. How further has that release cycle shrunk to? There are companies that have gone from having releases of once a week or once every 2 weeks or once a month to now having multiple releases a day. Indeed, some companies have up to 50 releases a day. This isn't something to also bear in mind is that each of those releases are tested and verified against test records so that you can guarantee that the code that's going to production is going to be good continuous code. So what are the differences between the different phases of DevOps? So effectively, there are 2 main phases of DevOps. There's the planning and coding phase, and then there's the deploying phase. And you have a tool such as Jenkins that allows you to integrate between both environments. Some of the core benefits that you may have to DevOps are going to be some technical benefits and some business benefits. So when somebody asks you what are the benefits of DevOps, you can reply that from a technical point of view, you're able to use continuous software delivery to constantly push out code that has been tested and verified against scripts that have been written and approved. You can be able to push out smaller chunks of code so that when you have an issue, you're not having to go through massive blocks of code or massive projects. You're going through just very small microservices or small sections of code, and you're able to detect and correct problems faster. On the business side, the benefits are absolutely fantastic. From a customer that's coming to your website or to your mobile app, they're going to see responses happening continuously so that the customer is always aware that you as a company are listening to their demands and responding appropriately. You're able to provide a more stable environment, and you're able to scale that environment to the demands of the number of customers that are using your services. So how will you approach a project that needs to implement DevOps? So this is really an exciting area for you to be in. So there are effectively 3 stages when it comes to actually working in a DevOps. The first stage is an assessment stage, and think of this as the back of the napkin ideation stage. This is where you are sitting with a business leader and they're giving you ideas of what they would like to see from feedback that they've had from their customers. This is blue sky opportunity. This is thinking of big ideas. That second stage, and this often comes as a fast follow to stage 1, is actually proving out that concept. So developing a proof of concept. And a proof of concept can actually be multiple different things. So it could be something as simple as a wireframe, or it could be something that is as complex as a mini version of the final application. Depending on the scope of the work that you're delivering will really depend on how complicated you want the POC to be. But with that in mind, whatever choice you make, you have to be able to deliver enough in the POC so that when you present this to a customer, they're able to respond to that creation that you've developed and able to give you feedback to be able to validate that you are going with the right solution and able to provide the right product to your customers. That third stage is where you get into your DevOps stage, and this is just the exciting part. This is where the rubber hits the road and you start releasing code based on a backlog of features that are being requested for the solution. In contrast to doing agile delivery where you just continuously work through a backlog, with DevOps, what you're also looking at is putting in analytics and sensors to be able to validate that you are being successful with the solution that's being delivered. So that once you actually start delivering out code that customers can interact with, you want to be able to see what are the pieces of the solution that they are using, what do they like, what is complicated, where are the failure points, and you want to use that data and feed that back into your continuous integration and have that as a means to be able to backfill the demand of work that gets completed in the backlog. So what is the difference between continuous delivery and continuous deployment? So continuous delivery is based on putting out code that can be deployed safely to production. It ensures that your businesses and functions are running as you would expect them to be. So it's going through and completing the code that you'd actually see. Continuous deployment, in contrast, is all about ensuring that you're automating the deployment of a production environment. So you're able to go through and scale up your environment to meet the demands of both the solution and the customer. This makes software development and release processes much more faster and more robust. So if we look here, we can actually see where continuous integration and continuous deployment come hand in hand. So when you actually start out with the initial pushes of your code, that's where you're doing your continuous integration and your continuous delivery. And then at some point, you want to get very comfortable with deploying the code that you're creating so that it's being pushed out to your production environment. One of the things that's great about working with the tools that you use in a DevOps continuous integration and continuous delivery model is that the development tools that you use, the containerization tools, the testing tools, should always reflect the production environment. And what this means is that when you actually come to deploying solutions to production, there are no surprises because your development team have been working against that exact same environment all the way through. So a question that you'll also be asked is, what is the role of a configuration management in DevOps? And so the role of configuration management really has 3 distinct areas. The first, and this is really obvious one, and this is the one where you probably already have significant experiences, is the ability to manage and handle large changes to multiple systems in seconds rather than days, hours, or weeks, as may have happened before. The second area is that you want to also demonstrate the business reasons for having configuration management. And the business reason here is that it allows IT and infrastructure to standardize on resource configurations. And this has a benefit in that you're able to do more with fewer people. So instead of having a large configuration team, you can actually have a smaller, more highly skilled team that's able to actually manage an even larger operational environment. And thirdly, you want to be able to highlight the ability to scale. So if you have configuration management tools, you're able to manage a significant number of servers and domains that may have multiple servers in. It allows you to effectively manage servers that are deployed on cloud or private cloud and allow you to do this with high accuracy. So how does continuous monitoring help in maintaining the entire architecture of the system? So when this question comes up, you want to dig in and show your knowledge on how configuration and continuous monitoring is able to control an entire environment. So the number one topic that you want to bring up when it comes to continuous monitoring is that with being able to effectively monitor your entire network 24/7 for any changes as they happen, you're able to identify and report those faults or threats immediately and respond immediately for your entire network instead of having to wait, as it happens sometimes, for a customer to email or call you and say, hey, your website's down. Nobody wants that. That's an embarrassing thing. The other three areas that you want to be able to highlight are the ability to be able to ensure that the right software and the right services are running on the right resources. That's your number one takeaway that you want to be able to give of continuous monitoring. The second is to be able to monitor the status of those servers continuously. This is not requiring manually monitoring, but having an agent that's monitoring those servers continuously. And then the third is that by scripting out and continuously monitoring your entire environment, you're creating a self-audit trail that you can take back and demonstrate the effectiveness of the operations environment that you are providing. So one of the cloud companies that is a strong advocate for DevOps is Amazon's Web Services, AWS, and they have really 5 distinct areas that you can zero in on for services. So when the question comes up, what is the role of AWS in DevOps? You want to really hold out your hand and list off 5 areas of focus using your thumb and finger. So you want to have flexible services, built for scale, automation, secure, and a large partner ecosystem. And having those 5 areas will really be able to help demonstrate why you believe that AWS and other cloud providers, but AWS is certainly the leader in this space, are great for being able to provide support for the role of DevOps. So one of the things that we want to be able to do effectively when we're releasing any kind of solution is to be able to measure that solution. And so KPIs are very important. So you will be asked for 3 important DevOps KPIs. And so 3 that really come to mind that are very effective. The first one is mean time to failure recovery. And what this talks about is what is the average time does it take to recover from a failure? And if you have experience doing this, then look at the experience you have and use a specific example where you are able to demonstrate that mean time to failure recovery. The second is deployment frequency. And with deployment frequency, you want to be able to discuss how often do you actually deploy solutions and what actually happens when you're actually doing those deployments and what does the impact to your network look like when you're doing those deployments. And then the third one is really tied to that deployment frequency, which is around what is the percentage of failed deployments. So how many times did you deploy to a server and something happened where the server itself failed? What we're looking for when you're going through and being asked for these KPIs is experience with actually doing a DevOps deployment and being able to understand what DevOps looks like when you're pushing out your infrastructure. And then the second is being able to validate that self-auditing ability. And one word of caution is don't go in there and say that you have 100% success. The reality is that servers do degrade over time. And you maybe want to talk about a time when a server did degrade in your environment and use that as a story for how you were able to successfully get over and solve that degradation. So One of the terms that is very popular at the moment is infrastructure as code. And so you're going to be asked to explain infrastructure as code. And really, it's something that actually becomes a byproduct of the work you have to do when you're actually putting together your DevOps environment. And infrastructure as code really refers to the writing of code to actually manage your environment. And you can go through many of the other tools that we've covered in this series, but you'll see that XML or Ruby or YAML are used as languages to describe the configuration for your environment. This allows you to then create the rules and instructions that can be read by the machines that are actually setting up the physical hardware versus a traditional model, which is having software and installing that software directly onto the machine. This is really important when it comes to cloud computing. There really is a strong emphasis of being able to explain infrastructure as a service, and infrastructure as code is fundamental to the foundation to infrastructure as service. And then finally, it allows you to be able to talk about how you can use scripted languages such as YAML to be able to create a consistent experience for your entire network. All right, so let's now get into the next section, which is source code management. And we're going to focus specifically on Git. The reason being is that Git is really the most popular source code management solution right now. There are other technologies out there, but for the types of distributed environments that we have, source code management with Git is probably the most effective. So the first question you'll be asked when it comes to Git is to talk about the difference between centralized and distributed version control. And if we look at the way that the two are set up, older technologies such as older versions of Team Foundation Server, though the current version does actually have Git in it, but older versions required a centralized server for you to check in and check out of code. The developer in the centralized system does not have all the files for the application, and if the centralized server crashes, then you actually lose all of the history of your code. Now, in contrast, a distributed model, actually we do check in our code to a server. However, for you to be effective and building out your solution, you actually check out all of the code for the solution directly onto your local development machine. So you can actually have a copy of the entire solution running on your local machine. This allows you to be able to work effectively offline. It really allows for scalability when it comes to building out your team. So if you have a team that may be in Europe, you can actually then scale that team with people from Asia, from North America or South America very easily, and not have to worry about whether or not they have the right code or the wrong code. And in addition to that, if the actual main server where you're checking in your code does crash, it's not a big deal because you actually have, each person has a copy of the code. So as soon as the server comes back up, you're able to check back in and everybody's running back as if there was nothing had happened at all. So one of the questions you'll be asked is to give the answer to some of the commands you use for working with Git. So if you were to be asked a question is, what is the Git command that downloads any repository from GitHub to your computer? On the screen we have four options. We have Git push, Git fork, Git clone, and Git commit. The answer in this instance would be Git clone. Now, if you want to be able to push code from your local system to a GitHub repository using Git, then first of all, you want to be able to do is connect the local repository to a remote repository. And in the example, you may want to talk about using the command git remote add origin and then the actual path to a GitHub repository. You could, if you wanted to, actually at this point also talk about other repositories such as GitLab that you can also work with, or a private Git repository that would be used just for the development team. Once you've actually then added the local repository into your local computer, then the second action you want to use is a push, which is to actually push your local files out to the master environment. So you use the command git push origin master. So one question you may be asked is, what is the difference between a bare repository and a standard way of initializing a Git repository? So let's look through what is the standard way. So the standard way using git init allows you to create a working directory using the command git init. And then the folder that creates is the folder that creates all the revision history related to the work that you're doing. In contrast, Using the bear way, you have a different commands for setting that up. So it would be git init -- bear, and it does not contain any working or checked out source files locally on your machine. In addition, the revision history is actually stored in the root folder versus a subfolder that you would have with the normal git init initialization. So which of the following CLI commands would you be used to rename a file? So we have git rm, git mv, git rm-r, or none of the above. Well, in this instance, it would be git mv. A question that you'll be asked around commit is going to be, what is the process to revert a commit that has already been pushed and made public? And there are two ways you can address this. The first is to actually address the bad file in the new commit, and you can use the command git commit -m and then put in a comment for why that file is being removed. The second is to actually create a new commit that actually undoes all the changes that were made with the bad commit. And then to do that, you would use git revert and then the commit ID, and the commit ID could be something such as 560E0938F, but you'd have to find that from the commit that you had made, but that would allow you to revert any bad files that you had submitted. So there are two ways of being able to get files from a Git repository, and you're going to be asked to explain the difference between git fetch and git pull. So git fetch allows you to fetch and download only new data from a new repository. It does not integrate any of the new data into your working files, and it can be undone at any time if you want to break out the remote tracking branches. In contrast, git pull updates the current head branch with the latest changes from the remote server. So you get all of the files downloaded. It downloads new data and integrates it with the current working files you have on your system, and it tries to merge remote changes with your local ones. So one of the questions you'll get asked about Git is, what is a Git stash? So as a developer, you will be working on the current branch within a solution. But what happens if you come up with an idea where it's something that will take a different amount of time for you to be able to complete, but you don't want to interrupt the mainline branch? So what you can actually do is you can actually create a branch that allows you to start working on your own work outside of the mainline branch. And this is called Git stash. It allows you to be able to modify your files without interrupting the mainline branch. So once you start talking about branching in Git, be prepared to answer and explain the concept of branching. So essentially what it allows you to do is have a mainline master branch that has all the code that the team is checking in and checking out against, but allows you to have an indefinite number of branches that allows for new features to be built in parallel to the mainline branch, and then at some point be reintroduced to the mainline branch to allow the team to add in new features. And so if we look through the merge and git rebase, these are the two features that you'd be using continuously to be able to talk about how you take a branch and merge it back into the mainline branch. So on the left hand side we have git merge, which allows you to take the code that you're creating and merge it back into the master. On the right hand side, what you have is a slightly different approach. This is for projects where you reach a point in a project where you go, okay, we're going to effectively restart the project at this point in time, and we want to ignore the complete history that's happened before that. And that's called git rebase, and that would allow you to rewrite the project history by creating a brand new mainline branch that ignores all other previous branches that have happened before it. You can, if you want to, very quickly and easily find out all the files that have been used to make a particular commit. So when somebody asks you the question, how do you find a list of files that has been changed in a particular commit, you can actually say that all you have to go is find the command git diff-tree-r and then the hash that you would use for the commit, and that would actually then give you a breakdown of all the files that have been made with that particular commit. A question that you'll be asked when you're talking about merging files is, what is a merge conflict in Git? and how can it be resolved? So essentially a merge conflict is when you have two or more branches that are competing with commits in Git, and you have to be able to determine which is the appropriate files that need to be submitted. And this is where you would go in, and to actually help resolve this issue, you'd actually go in and manually edit the conflicted files to select the changes you want to keep in the final merge. So let me go through the steps that you would take to be able to illustrate this when you're talking about this particular question in your interview. There are essentially 4 stages. The first would be under the repository name, you want to select a pull request, and you want to be able to show how that pull request would be demonstrated inside of GitHub. So within the pull request, there's going to be a highlight of conflict markers, and you'll be able to select which conflicts you want to keep and which you want to merge and which ones you want to change. So it's a step through how you would actually resolve a merge conflict. The first step would be under GitHub. You want to be able to pull the repository name and then the pull request around that repository. In the pull request list, click the pull request with a merge conflict and that you'd like to be able to resolve. And that will pull up a file that will list out all of the conflicts for you. Near the bottom of that file will be a list of the requests that need to be resolved. And then if you need to make a decision on which branches you want to keep or which ones you want to change, that will have to be something you have to put in instructions inside of the file. You'll actually see that there are conflict markers within the instructions which are going to ask you which files you want to change and which ones you want to keep. If you have more than one merge conflict in your file, scroll down to the next set of conflict markers and repeat steps 4 and 5 until you resolve all of the conflicts. You will want to mark your file as resolved in GitHub so that the repository knows that you are having everything resolved. If you have more than one file with a conflict, then you want to go then onto the next file and start working on those files and just keep repeating the steps we've done up to this point until you have all of the conflicts resolved. And then once you have all of the resolutions created, then you want to select the button which is commit merge and then merge all your files back into GitHub, and this will take care and manage the resolution of the merge conflict within GitHub. So you can also do this through command line, and with the command line you want to use git bash, and so you want to, as a first step, open up git bash and then navigate to the local git repository in command line using the cd change directory, and then list out the actual folder where you actually are putting all of your code. And then you want to be able to generate a list of the files that are affected with the merge conflict. And in this instance here, you can actually see the file styleguide.md has a merge conflict in it. And as before, with working with GitHub, you actually go through and use a text editor, and you can use any text editor. But as you go through and edit out what you want to keep and what you want to manage in your conflict, so you actually have a resolution that's being created, so that you'll be able to then, once you're using the conflict markers, you can actually merge your files together so that the solution itself will allow you to incorporate your commits effectively into the resolution. Once you've gone through and applied your changes, you're able to then merge the conflicted commits into a single commit and able to push that up to your remote repository. All right, let's talk about the next section, which is continuous integration with Jenkins. So the first question you'll be asked about with Jenkins is explain a master-slave architecture of Jenkins. So the way that Jenkins is set up is that the Jenkins master will pull code from your remote Git repository, such as GitHub, and will check that repository every time there is a code commit. It will distribute the workload of that code and the tests that need to be applied to that code to all of the Jenkins slaves. And then on request, the Jenkins master and the slaves will then carry out all the builds and tests to be able to produce test reports. The next question you'll be asked is, what is a Jenkins file? And simply put, a Jenkins file is a text file that has a definition of the Jenkins pipeline and is checked into a source code repository. And this really allows for 3 distinct things to happen. One, it allows for a code review and iteration of the pipeline. It permits an audit trail for that pipeline, and also provides a single source of truth for the pipeline, which can be viewed and edited. So which of the following commands runs Jenkins from the command line? Is it java-jar jenkins.war, java-war jenkins.jar, java-jar jenkins.jar, java-war jenkins.war? And the answer is A, java-jar jenkins.war. So when working with Jenkins, you're going to be asked what are the key concepts and aspects of working with a Jenkins pipeline. And you want to really hold out your fingers here and go through 4 key areas, and that is pipeline, node, step, and stage. So pipeline refers to the user-defined model of a CD continuous delivery pipeline. Node are the machines which are part of that Jenkins environment within the pipeline. Step is a single task that tells Jenkins what to do at that particular point in time. And then finally, stage defines a conceptually distinct subset of tasks performed through the entire pipeline. And tasks could be build, test, and deploy. So which of the following file is used to define dependency in Maven? And do we have A, build.xml, B, pom.xml, C, dependency.xml, or D, version.xml? And the answer is pom.xml. Working with Jenkins, you're going to be asked to explain the 2 types of pipeline used in Jenkins along with the syntax. And so a scripted pipeline is based on GroovyScript as their domain-specific language for Jenkins. And there are 1 or more node blocks that are used throughout the entire pipeline. On the left-hand side, you can actually see what the actual script would look like, and the right-hand side shows what the actual declaration for each section of that script would be. The second type of Jenkins pipeline is a declarative pipeline. And a declarative pipeline provides a simple and a friendly syntax to define what the pipeline should look like. And then you can actually, at this point, use an example to actually break out how blocks are used to define the work completed in a declarative pipeline. So how do you create a copy and backup of Jenkins? Well, to create a backup, periodically back up Jenkins to your Jenkins home directory, and then create a copy of that directory. It's really as simple as that. A question you'll be asked as well is how can you copy Jenkins from one server to another? Well, there are 3 ways to do that. One is you can move a job from one installation of Jenkins to another by copying the corresponding job directory. The second would be to create a copy of an existing job directory and making a clone of that job directory but with a different name. And the third is to rename an existing job by renaming a directory. So security is fundamental to all the work that we do within DevOps, and Jenkins provides the center core to all the work that gets completed within a DevOps environment. There are 3 ways in which you can apply security to authenticate users effectively. And when you are asked about this question of security within Jenkins, the 3 responses you want to be able to provide is A, Jenkins has its own internal database that uses secured user data and user credentials. B is you can use a LDAP or lightweight directory access protocol server to be able to authenticate Jenkins users. Or C, you can actually configure Jenkins to authenticate by using such as OAuth, which is a more modern method of being able to authenticate users. You're going to be asked how to deploy a custom build of a core plugin within Jenkins. And essentially, the 4 steps that you want to go through are, first of all, copying the .hpi plugin file into the Jenkins home plugins subdirectory. You want to remove the plugin's development directory if there is one. You want to create an empty file called plugin.hpi.pinned. And once you've completed these 3 steps, restart Jenkins and your custom build plugin should be available. How can you temporarily turn off Jenkins security if the administrative user has locked themselves out of the admin console? Well, this doesn't happen very often, but when it does, it's good to know how you can actually get into Jenkins and be able to resolve the problems of authenticating effectively into the system as an administrator. So when you want to be able to get into a Jenkins environment, what you want to be able to do is locate the config file. You should see that it's set to true, which allows for security to be enabled. If you then change the user security setting to false, security will be disabled enabled allow you to make your administrative changes and will not be re-enabled until the next time Jenkins is restarted. So what are the ways in which a build can be scheduled and run in Jenkins? Well, there are 4 ways in which you can identify the way a build can be scheduled or run in Jenkins. The first is when source code management commits new code into the repository. You can run Jenkins at that point. The second can be after the completion of other builds. So maybe you have multiple builds in your project that are dependent on each other, and when so many other builds have been executed, then you can have Jenkins run. You can schedule builds to run at a specified time. So you may have nightly builds of your code that illustrate the changes in the solution you're building. And then finally, you also can manually build an environment on request. Occasionally, you will want to also restart Jenkins. And so it's good that when a question around how do you restart Jenkins manually comes up, that you have the answers. And there are 2 ways in which you can do it. One is you can force a restart without waiting for builds to complete by using the Jenkins URL that you have for your environment /restart, or you can allow all running builds to complete before restart are required, and in which case you would use the command of the URL for your Jenkins environment /safe restart. So let's go into the 4th and final section of this first video, which talks about continuous testing with Selenium. So the first question you will be asked most likely around Selenium are, what are the 4 different Selenium components? And again, you will want to hold open your fingers because there are 4 distinct environments. You have Selenium Integrated Development Environment, or Selenium IDE. You have Selenium Remote Control, or Selenium RC. You have Selenium WebDriver, and then Selenium Grid. You'll be asked to explain each of those areas in more detail, but let's start off by looking at Selenium Driver. What are the different exceptions in Selenium WebDriver? So it's useful to remember that an exception is an event that occurs during the execution of a program that disrupts the normal flow of that program's instructions. And so we have 4. We have a timeout exception, an element not visible exception, no such element exception, and a session not found exception. And each of those, if we step through them, are the 4 different types of exceptions that can be thrown up when using the Selenium WebDriver. So as we evolve in our digital world with the different types of products that are available for us to be able to build solutions onto multiple platforms, you're going to be asked, can Selenium and other DevOps tools run in other environments? And so a good question around this is, can Selenium test an application in an Android web browser? And the short answer is absolutely yes, it can. But you have to use the Android driver for it to be able to work. So you want to be able to talk about the 3 different types of supported test within Selenium. So when the question comes up, what are the different test types supported by Selenium, you can answer it. And there are 3 different types of test. First is a functional test. Second is a regression test, and third is a load testing test. The functional test is a kind of black box testing in which test cases are based on a specific area or feature within the software. A regression test helps you find any specific areas that functional tests or non-functional areas of the code wouldn't be able to detect. The load testing test allows you to monitor the response of a solution as you increase the volume of hits and how you're using the code are put onto it. An additional question you'll be asked is, how can you get a text of a web element using Selenium? Well, the get command is used to retrieve text of a specific web element. It's important to remember, however, that the command does not return any parameters, but just returns a string value. So you want to be able to capture that string value and discuss about it. A question you'll be asked around Selenium is, can you handle keyboard and mouse actions using Selenium? And the answer is yes, you can, but you have to make sure that you're using the Advanced User Interaction API. And the Advanced User Interaction API is something that can be scripted into your tests, and it allows you for capturing methods such as a click and hold and drag and drop mouse events, and then keyboard down or keyboard up key release events, so that if you want to capture, say, the use of Control Shift or a specific function button off the keyboard, you'd be able to capture those. Of the following 4 elements, which of these elements is not a web element method? A, get text, B, size, C, get tag name, D, send keys. And it's B, size. You're going to be asked to explain what is the difference for when we use find element or find elements. And so if we look at find element finds the first element in the current web page that matches the specified locator value. In contrast, find element finds all of the elements on the web page that matches the specified value. When using WebDriver, what are the driver close and driver quit commands? And these are 2 different methods used to close a web browser session in Selenium. So driver close will close the current web browser on which your focus is set, and driver quit closes all the browser windows and ends the WebDriver session completely. The final question that you are likely to be asked in using Selenium is, how can you submit a form using Selenium? Well, in this instance, that's relatively easy. The following lines of code will let you submit a form in Selenium, which would be web element el equals driver.findElement, and then you put in the ID and the element ID, and then l submit, open close parentheses, semicolon. That's the end of our first of 2 parts of a video that covers how you can actually answer questions in a DevOps interview. Please stick around. We have part 2 coming out right after this. You've probably got a video on the screen that already links to that. And the second video will actually take you through containerization, Docker, and all the other questions that would be used for completing a comprehensive DevOps interview.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.